Dear students, today's class we are going to talk about the query processing and optimization. So, in the query processing and optimization, these are all the topics I'm going to cover: query processing, translating SQL queries into relational algebra, algorithms for select and join operations, project and set operations, aggregate operations, and outer join, materialization, pipelining. These are all the topic which I am going to present here. So, so query optimization is nothing but choosing a suitable execution strategy for processing a query. How a query has to be executed. That you are going to give a proper plan so that you know you are optimizing the query, right? Okay. There are two internal representation of a query. So one is a query tree, another one is a query graph. Either you can go with the tree structure or you can go with the graph structure. So this is about the query processing. Okay. So first what you have to do is you have to give the query in a high level languages. So Java or any other language you have to give. So you are scanning, parsing and validating the query. So that query has been validated. Okay. So and then it is going to the query optimizer. Okay. Suppose you know you have four logical operations. Okay. So in that case, which logical operation has to be processed first? Okay. So like this, you have to select it, right? Okay. So and you have to execute the plan, right? You have to execute the plan and the query code generator. Okay. So now the code is generated to execute the query and we are getting the result of query. Okay. So this code is entering into the runtime database processor. Then you are getting the results of query. Okay. So you have to know one thing, whatever the query is there, so you have to scan and take the query and you have to plan it, which you are going to do it first. Like that, you have to plan it and it has to go to the query code generator. And when the code is going to a runtime database processor and we are getting the results of the query. So the first one is translating SQL queries into relational algebra. As you know, the normal queries, how to write the normal queries. For example, employee table is there. So you can give select star from employee where employee number is equal to 1. This is a query, normal query. So even nested queries you can able to take it. Okay. So in the nested queries, a query within the query. Okay. So inside one query, there is another query you can able to use it. Okay. That is a nested query, right? Okay. So here you are translating SQL queries into a relational algebra. So this is a query which we have taken. Select last name, first name from employee is the table where salary greater than, select maximum of salary from employee where department number is equal to 5. So this is one of the query. This query is nested here. So here this maximum is an aggregate operation, right? Okay. So this query we are splitting into two. Okay. So salary greater than the condition, the C is taken. What is C? That is select maximum of salary from employee where the department number is equal to 5. Okay. So here in the translating the relational algebra operations, so you have to give the pi symbol, you have to use it for the project operation, projecting the last name and first name, and from employee table that is given in the bracket. So the condition we have given like this, salary greater than C. Okay. So here also for the aggregate operation, we are giving this symbol and maximum salary. So here, for the condition, we are giving department number is equal to 5 and employee is the table which we are giving here. Okay. So, so for the uh, select operation, SSN is equal to the number, SSN number we are giving for the employee table. So this is another select operation, department number greater than 5. So department is the table. So here this is another condition which we are using. So here department number is equal to 5 for the employee table. Here there are three condition which we have used. Department number is equal to 5, salary greater than 30,000, and sex is equal to F. Okay. So like this, you can use the different queries you can able to use it. Okay. So there are other operations are there, aggregation. Okay. So in the aggregation, normally, we will be doing count, minimum, maximum, sum you are calculating. Okay. These are all the things which are, used for the aggregation. So normally the aggregation is used for optimization. Count is for calculating the number of record. Minimum is for the minimum value. Maximum is for the maximum value. And the sum is what is the total sum for the particular attributes. Even other set operations are there. As you know about the set operations, we have, union, intersection, or minus S. Okay. These are all the different set operations are there. So different types of SQL join operations are there. Okay. So here you see, when you see the diagram, you can able to understand, uh, what is exactly about the join operation. Okay. So this is an inner join. Okay. Table 1 intersect table 2. This is a left join. Okay. So table 1 completely we took it. Right join is table 2 completely we took it, and full outer join is, both the things we took it. Right. Okay. So inner join, so both tables matching values are, given in the inner join. Left join, okay, it is taken from the left table, and right join, it is taken from the right table. Okay. So full outer join is both the things it is taken. Okay. So this is a different notations for the operations. Union, we are using this symbol. Intersection, set difference. Projection, you are using this one. Selection, Cartesian product. For join operation, we have various symbol. Join, this one we are using. Left outer join, we are using this one. Right outer join, we are using this one. And the full outer join, we are using this one. Okay. So now we have to talk about the evaluation of expression. In this one, you have to talk about materialization and pipelining. Okay. So materialization is intermediate results are stored. Okay, that is a materialization. You're storing something that you can access it later. But pipelining is the one, we are just passing the information. So let me repeat. Materialization is, the results are stored. Okay. But pipelining is we are just passing the information. Okay. So see this one. So in this one, building it's equal to Watson. So this information will be temporarily stored and instructor information will be stored. Okay. Then we are combining that one. So after taking the join operation, again it will be stored and we are selecting the information. So it is the intermediate results are stored here in the materialization. Okay. So now, when you see the cost of the materialization, so individual operation cost you have to take it plus intermediate results. Okay, cost of writing intermediate results to disk. So that is also we have to take it. Okay, so that is what the overall cost is calculated. Okay. So, so the double buffering is two output buffers for each operation. When one is full, write it to disk while the other is getting filled. Okay. So that is what called as a double buffering, right? Okay. Now, so how this pipelining is work? So in the pipelining, we are not storing it, temporarily. So here you see, it is directly, the calculations are directly coming to the next building Watson. So that is also coming, instructor is also coming. Then we are processing it and the end results we are just giving it. That is what the pipelining. Okay. So in the pipelining, we have two ways of pipelining. One is a demand driven pipelining, and another one is a producer driven pipelining. Okay. So in the in the demand driven, okay. So it is just request the system repeatedly requests next tuple from the top level. Actually, demand driven, it is moving from the top level operation. Okay. So here, it has to maintain the state. What is the next state? It has to maintain it. Okay. So each operation requires next tuple from children operation as required in order to output its next tuple. So in the demand driven, you are maintaining from the top level operations. It should maintain the state. Then the next one is the producer driven or eager pipelining. Okay. So so here the producer driven, the produced operators produce tuples eagerly and pass them to parents. So this is happening from the bottom level. Okay. So it is passed to the parents. Okay. So buffer is maintained between operator. Child is, putting the buffer. Okay. Parents is removing tuples from the buffer. There will be a buffer. In that buffer, the information will be put and the parent will remove tuples from the buffer. Once the buffer is full, the child has to wait, okay, till there is a space. Okay. So that is what producer driven. Okay. It is an alternate name as pull and push models of pipelining, right? Okay. So in the demand driven pipelining, each operation is implemented as an iterator implementing the following operation. These are all the following operations are there. One is open, okay, and another one is the next and the close operation. Okay. So first we have to initialize the file scan. Okay. For the open. Okay. Then, merge, join, or sort relations. This and all you have to do it, right? Okay. Then next, okay. So the next output for file scan. Okay. Next, the pointer has to move to the next one. Okay. So, and the last one is the close operations. Okay. So, thank you all.